states of matter. The matter is divided into three states, that is solid state, liquid state and gaseous state. Now while coming to solid state, the solid state is the state where a substance or a matter which does not change its shape or which does not change its physical form while it is placed in different types of atmosphere. That is, for example, let us collect a pen and sketch the shape of a pen using a pencil and passing over the shape, and let us see what is the shape of that pen. That means it is having the definite shape. That is, the property of a pen is it is having a definite shape. It does not change in any form or at any temperature, and at the same time it has a distinct boundaries. The boundaries of that will not be extended or it will not be diminished. At the same time it has a fixed volume. The mass and the volume are fixed for a solid state matter. At any area of time, at any point of time, at any temperature, at any atmosphere, the solid state does not change its shape on any matter. For example, let us take solids. If we try to compress it or we give an external force on a solid state or a solid particle like a stone or pen or so anything, whatever it is, what we can touch and it is in a solid form, then it does not change its shape. And at the same time, when we give external force very much, then it tries to be break up, but it does not change its shape. That is the main property of solid matters. And while coming to another example, that is, let us take rubber band, sugar or salt or sponge. Is these three are solid matters? Let us see. Now suppose let us take rubber band. When we give a force on it, when we elaborate it, it will be changed into some other shape, right? When we leave that force or when we suppress that external force, then it will be coming into its normal position. At the same time, when we give extra force, then it will be tried to be broken up. That means it is the elasticity property of a rubber band. At the same time, sugar or salt, when we take it in a hand, it does not change its shape. When we take it in on a paper, it does not change its shape. But when we keep sugar or salt in water or any liquid form of state, then it will dissolve in it and we cannot see the shape of sugar or salt. And at the same time, when we take sponge, when we keep it in water, it will be absorbing the water, the spaces in that sponge that will be filled with the water. At the same time, when we compress, when we expel it, the water will be coming out. These three forms are not exactly solid forms. Means they are changing their shape and they are changing their physical form by dissolving in water. Either they are changing their external properties, that is physical properties, by when we keep some force. Therefore, we can conclude that a matter should have some properties in order to fulfill it as solid state matter. That is, it does not change its shape. That is, it has a definite shape and it has a limited boundaries and it has a fixed volume. These three properties are constituted by a solid state matter. Let us take, suppose when we hammer it or when we pull any solid object or when we compress, it does not change its shape, and that is means that it has negligible compressibility and it doesn't have any attractive forces, and it doesn't mean it cannot be compressed. That is the main property of a solid state matter. Liquid state and gaseous state. Now we are seeing them in a form of pictorial representation in order to get a brief understanding. That is, see, for example, let us take a solid state material, that is a chalk. Now see, let us take a small part of a chalk and let me examine those particles in that a part of chalk. We will be seeing those particles are closely packed up and having a less space or less volume in between those particles. The distance between those particles is very less. That is, they cannot move freely and they have no minimum space between each other. They are collided with each other and they are in contact with each other. That means the particles are very close to each other. At the same time, when we take the liquid state form particles, that is, for example, let us take a container containing of liquid, that is water or oil, anything. Then let us observe those particles, how they are collided with each other. That is, those particles are having a large space in between them. The spaces in between those particles are more than solid state particles, and they can move freely. That means not more freely but little freely, and they can move randomly with each other. And let us take the gaseous state particles. For example, let us take a balloon filled up with air, and let us see those particles, how they are collided with each other. That is, those particles are very freely in the space. That is, the space between those two particles is more, and they can move randomly, and they can move very fastly from each other, and they can move very fastly from one position to other. They can collide. That means the particles will be colliding each other, and the container walls, that is the walls of the container, that is the balloon or water container jar or anything, and the force will be exerted between those particles, and the exerted force will create the force between those particles, and thus the speed of the particles will be increased. Therefore, we can conclude that the gaseous state particles move randomly with high speed, and the gaseous state particles can diffuse at high speed and can be moved at high speed and can be compressed at high speed. Now let us take one more example, that is, can matter change its state? Does the matter can change its state? That means a solid state particle can move into liquid state particle or liquid to gaseous state position, or that means any particle or any object can change its position, or can it change its matter from one position or one state to another state? That is, yes, because we can say yes, because a matter can change its position from one state to another. That is, we can give the best example, that is water. Water, it is in liquid state form, right? And water can be converted into solid state form, that is ice. And at the same time, water can be changed into gaseous state form, that is water vapor. At the same time, we can say that is a gas, it is water vapor, solid it is ice, and liquid it is water. That is, water have three states, that is solid state, liquid state and gaseous state. At the same time, we can know more how the changes, what are the changes are going to be done inside the matter during the change of state from one state to another. Now, the most important point what we learned here is mass per unit volume of a substance. That is, the amount of mass, that is the volume or the amount, the kgs, everything, whatever it may be, how much weight it contains, it is measured per unit volume. Volume is the space occupied. See, for example, let us take one particle. This particle weight and this particle occupied space, that is mass per unit volume. It is defined as density. The mass per unit volume of a substance is called as density. Density equals to mass per unit volume. It is a very important formula we will be using in calculations. That is, density equals to mass by volume. Mass is the substance weight occupied by that particle, and volume is the space occupied by that particle. That is equals to density. And at the same time, the gaseous state particles have an increasing density because they have high speed of motion. By these three diagrams, we can conclude that we can state or we can differentiate both the positions and motions and the spaces between those particles. Thus, we can differentiate both solid state, liquid state and gaseous state particles. Now let us see one more activity, how the state of a matter converts or transforms from one state to another. That is, how the matter converts from solid state to liquid state and liquid state to gaseous state. That is, let us see one more example or activity, how the solid state ice will be converted into a liquid state form water. That is, let us take one activity that is known as, suppose take a iron stand and with the help of an iron stand, place a jar and keep a burner in order to heat up and place an ice cube or ice in jar and heat it with the help of the burner. And at the same time place a thermometer in order to measure the temperature, and at the same time place glass stirrer in order to mix the ice. Now we have taken every equipment or every container what we needed, and now let us start the procedure. First, start heating, placing the ice in the container with the help of burner. When we continuously heat up, we will be seeing at one state that ice will be melted and ice will be converted into water. Now, second step, we have to note the temperature when the solid state form ice is being converted or transformed or changing its position from solid state to liquid state. And at the same time, third point what we note is at what time or at what point of temperature that all the ice is converted into liquid form, that is water. Now let us take one more point, that is we have to record all these observations, and next we have to take a glass rod and we have to place our eye on thermometer, and we have to exactly note the point or degree or temperature at which solid is melted into liquid form. And the same procedure is continued for conversion of how the liquid state from water is converted into gaseous state from water vapor. In that time we will be placing water in the place of ice for water to water vapor state. The same procedure will be repeated for liquid state to gaseous state also. Now let us see, and we have to record all those observations for same gas to solid to liquid and liquid to gas. All these observations will lead to us that at a particular temperature that solid state ice will be changed into liquid state water, and at a particular temperature water state liquid will be changed into gaseous state water vapor. And this is the procedure, or this is the thing what is going inside the matter when it is converted from one state to another. This is known as conversion of ice to water and water to water vapor. And at the same time we will be seeing one more important point, that is when the temperature is increased. See, we are taking a burner and we are heating up the ice or water. At the time when we are heating up, the temperature is raised, right? At the same point, when the temperature of solid is increased, the kinetic energy of the particles is increased. Therefore, the speed or the motion of particles will be increased, and therefore they will be losing the attractive force between those particles by the help of temperature. They will be overcoming the attractive force or compressive force between those particles, and thus they will be separated or break down the forces between them, and they move up freely. Thus they will be changing into one form to another. And at the same time the vibration of the particles will be increased. Thus the speed increase due to temperature rise. And at the same point we will be seeing energy is transformed in the form of heat. Yes, we are seeing now heat energy is converting into, means that it is breaking up the chemical energy. The chemical bond or chemical attraction between those particles is breakdown by the help of heat energy, that is rise in temperature. Now, thus we can see that energy conversion is taking place, that heat energy to chemical energy breakdown. And at the same time, fourth point is what we noted down is the attractive force will be loosed, and they will lose the fixed position. They will leave those fixed positions at what point they are situated, and thus they move freely from one state to another. Means the position they want, what place they are fixed, will be moving from those position, and they will be freely moving in that container. Thus we will be getting liquid state from water. Now all these four observations will leading us to an important point, that is the position or the point where the solid state form is converted or changing into liquid state form is known as melting point. Melting point means the conversion of solid state to liquid state. That is known as melting point of a water or melting point of solid ice. And at the same time the water to water vapor also it is known as melting point. Okay.